Welcome back to Mr. DuPage's classroom. This lesson is from Algebra 1 class. It is 5.3 function rules, tables, and graphs, day 1. Review independent variable versus dependent variable. We need to identify the independent variable and the dependent variable quantities in each situation. Go ahead, give yourself some time. Try 1, 2, and 3 on your own. Come on back and let's see how you can do. All right, welcome back. Let's see how you can do. Number 1, a runner averages 7 miles per hour. The independent and dependent variable is what we are looking for. The independent variable will be the amount of time that the runner is going to run. The dependent variable is going to be the distance that the runner can cover. So depending on how long the runner runs for, that is the distance that we can figure out. A customer can buy a dozen apples for $2.40. So overall, my independent variable would be the number of apples, because it depends on the number of apples for what my dependent variable would be, which is the price. Oops, misspelled price. Wow. The price. Okay? The cooking time for a turkey and the weight of the turkey. Well, the independent variable here is going to be the weight of the turkey. The dependent variable is going to be the cooking time, because the cooking time depends on how large the turkey is. All right. Let's move on to our lesson. A function can be modeled using 3 things. We've talked about this before. In this section, I will give you the rule, and you must create a table and a graph. In the next section, we'll be creating a rule from a table or graph. But in this case, the first one, a function model can be modeled using an equation. Can be modeled using equations. It also can be modeled using tables. And it can be modeled using graphs. Like I said, we are going to be concentrating on tables and graphs today. All right? Example 1. Model the function rule f of x is equal to 3x plus 4 using a table and a graph. What I want to do here is I need to plug some things in for x to find my f of x or my y so that I can go ahead and graph it. How I normally would do this is I'm just going to go ahead and use 0, 1, 2, and 3. All right? So to find f of x, or f of 0 in this case, if I put 0 in for x, it would be 3 times 0 plus 4, which is equal to 0 plus 4, which is equal to 4, which is the substitution stuff we have done in the past. To find f of 1, I just put 1 in for all the x's, so 3 times 1 plus 4, which is 3 plus 4, which equals 7. So 7 will go there. For x is 2, it would be 3 times 2, which is 6, plus 4 would equal 10. And for x is 3, right here, it would be 3 times 3, which is 9, plus 4 would be 13. Okay? So now I need to go ahead and graph this. Remember that this is my x-axis, so when my x is 0, I'm going to be looking at this point here. My y-axis is the vertical line, so 0, 4 would be there. Go ahead and make a large point. 1 on my x-axis is here, 7 on my y-axis is there, so make a large point there. 2 on my x-axis is here. 10 on my y-axis is there, so we'll make a large point there. And 3 on my x-axis is here. 13 on my y-axis is there. Make a large point there. From here, what I need to do is just go ahead and connect all of the points. If you have a straight edge via book or folder, you can make your line a little straighter than I did. All right? On to the next one. At a local video store, you can rent a video game for $3. It costs you $5 a month to operate your video game system. The total monthly cost, which is represented by C of V, cost of video games, depends on the number of video games you rent. Use the function rule. C of v equals 5 plus 3v to make a table of values and graph. Again, what I'm going to do is go ahead and use 0, 1, 2, and 3. So C of 0 will equal 5 plus 3 times 0, which would be 5 plus 0, which just in fact is 5. For C of 1, it would be 5 plus 3 times 1, 5 plus 3, which is 8. C of 2 is equal to 5 plus 3 times 2, should be 5 plus 6. It's equal to 11. And if I were to go ahead and do C of 3, it would be 5 plus 3 times 3. Well, 3 times 3 is 9. 5 plus 9 would be 14. So I can put 14 in for 3, 11 in for 2, and 8 in for 1. Now, I'm going to go ahead and graph this. Again, 0 on my x-axis is there, 5 on my y-axis is here. So I'm going to go ahead and make a point. 1 on my x-axis, 8 on my y. 2 on my x, 11 on my y. 3 on my x, 14 on my y. Now the question I have for you in this situation is, can I actually have any video games that are partially, that I can rent a partial video game, I should say. Can I rent half of a video game? Not really, all right? That's going to become important in a second. The first question it asked on here is, why doesn't your graph start at 0, 0? Well, the reason it doesn't start at 0, 0 is because it costs $5 to run the system. So whether or not I actually rent a game, it's going to cost me $5 to run the system. Can you think of a situation where your data would be incorrectly represented on the graph if you connected the points? Well, in this situation, I cannot connect these points because I can only rent full video games. So I can only go up 1 on each X value. So the data in between here and here would not exist because I cannot rent a partial video game. Does that make sense? I hope. Okay. So it would be incorrectly represented on a graph if I connected the points because you can't rent a partial game. So I actually would have to stop it there. What I could do is go to 4. That would take me up to 17. I could go to 5. That would take me up to 20. And now my graph is full. But I could not connect those points because the information in between each point is not an actual solution. Okay? So what if you were purchasing tickets to a baseball game? How about buying hot dogs for your friends? If you were purchasing tickets to a baseball game, could you buy a partial ticket? Could I buy half of a ticket? No, I could not. For every person that shows up, they need a full ticket. Same thing with a hot dog. I can't buy just a bite of hot dog. I'm going to have to buy a whole hot dog or nothing at all. So discrete data is data that involves counting items. That's going to be data that is like the video game problem or buying tickets to a baseball game or buying hot dogs. Does not allow for decimals or fractions. Okay? Continuous data is where it has data where the information between points has meaning. Okay? The information in between points has meaning. So that would be something along the lines or something where I can have something partial. Trying to think of a situation where that would occur. Well, really, the easiest way for me to explain this, I guess, would be back at example 1. It's not a story problem, I'm aware, but on example 1 here, all of the information on that line is part of our solution. So the information in between the data points actually has meaning. So it can, in fact, have decimals and fractions. Okay? All right. On to example 3. The function c of t equals 6.5t. It represents the cost of t tickets to a baseball game. Is this discrete or continuous? So can I have a partial amount of something, or can I not have a partial? Well, we already talked about the fact that tickets to a baseball game, I cannot have partial tickets, so it will be discrete. Why? Because, again, I cannot... Well, I don't want to write that there, I'm sorry. I can't buy a partial ticket so now we need to go ahead and make a table of values and graph it. So again, just like we've been doing recently, I'm going to go ahead and use, these are my x values, these are my y values, 0, 1, 2, 3, and 4. So if I buy 0 tickets to this baseball game, that would be the cost of 0 tickets. It would be 6.5 times 0, which is 0. The cost of 1 ticket to the baseball game would be 6.5 times 1, which is 6.5. The cost of 2 tickets to a baseball game would be 6.5 times 2, which equals 13. The cost of 3 tickets to a baseball game would be 6.5 times 3, which would actually be $19.50. The cost of 4 tickets to a baseball game would be 6.5 times 4, which would actually be $26. Now, you're going to say, well, I didn't think I could have a decimal or a fraction. You can have a decimal and a fraction in this problem or in the y values only. I cannot have it in the x values, so I can't have 1.5 tickets. I hope that makes sense to you. I can't have 1.5 tickets. So in my y values, these points can, in fact, be decimals, but my x values cannot, because those are my independent variables. So when we're talking about continuous versus discrete, and we say that they can have decimals with the continuous, they cannot have decimals with the discrete, it's really talking about the fact that I cannot have decimals in my independent variable, okay? So I know this is a graph where I have an x and y axis, but we're not actually going to use the x and y axis right now. I'm going to make this 0, 0 down here, okay? So then I'm going to go to 1, 2, 3, and 4. Going up the y axis, I'm going to go up by 2's, so that's actually 4, 8, 12, this would be 16. I'm going to erase our cost of 4 tickets real quick. And 20. All right. Which I need to actually continue. This would be 24 and 28. So each little tick mark there going up is actually worth $2. All right. So I need to go ahead and graph this. Well, 0, 0 is my first point. Then I got a 1, 6.5. Well, this is 4, which means that's 6, which means I want to be just above that line for our 6.5. 2, 13, here's 12. So 13 would be just a point above that point, or that line right there, or halfway in between, really. 3 is going to be 19.5, so just below our 20. And 4 is going to be 26, so it should be right in between 24 and 28. The question I have for you now, though, is can I actually connect those points? Well, I cannot, because there is no data in between 0 and 1. If I connect it, I say that the line is part of my answer, and it cannot be. We need to make sure that we go ahead and label both the x and y axis. So the y axis was money, the x axis was tickets. Okay? Your family is hiking uphill from a campsite 4,000 feet above sea level. You climb an average of 500 vertical feet per hour. The function h of t, or hours, h of time, is equal to 4,000 plus 500 t. It relates time, t, to your height above sea level, h. Okay? Is this going to be discrete or continuous? So can I have a partial hour? Could I have a half hour or 15 minutes or 5 minutes? Yes, I can. So in that case, this is going to be continuous because I can have a partial hour. Now, because this is going up by 500s, I'm going to go ahead and, I'm going to go ahead and keep it the same. So I'm going to label this 0, 1, 2, 3, 4, 5. I'm going to make each tick mark 500. But it told us that we started at 4,000 feet. So what I really want to make this 0, make each line 500 to get to 4,000 feet to even start. That doesn't really make sense, does it? So what we're going to do is we're going to make our bottom line 4,000 and go up by 500 at each point. If we need to continue, we will, but right now I'm going to stop at 6,000, okay? So if our family is hiking uphill, can we have no time at all where we've been hiking? Yes, we can. Remember, this is your x, this is your y. On our x-axis down here at the table, this is our time in hours, and this is our height above sea level. Okay? So for h of 0, it would be 4,000 plus 500 times 0. Well, 500 times 0 would be 0, so this would be 4,000 plus 0, which is 4,000. So at time 0, our height is 4,000. In 1 hour, what would our height be? Well, it would be h of 1 is equal to 4,000 plus 500 times 1, which would be equal to 4,000 plus 500, which would be 4,500 feet. So in 1 hour, we'd be at 4,500 feet. In 2 hours, again, I need you to show I haven't really said this yet, but you really need to show your work for each number that you put in for x, or in this case t. But I am running out of space, so I'm not going to do it right now. Okay. So in 2 hours, I would be at 5,000 feet. In 3 hours, I would be at 5,500 feet. And at 4 hours, I would be at 6,000 feet. So you guys really need to do this for every x value that you're going to put into place. All right. So my first point will be at 0, 4,000, 1, 4,500, 2, 5,000, 3, 5,500, 4 would be at 6,000. In this case, I can connect all of these points because I could have a partial hour that I have been walking. That is the lesson for the day. The biggest things to remember here are if I have a discrete data, that means I'm involving just counting items, which would be like 1 shirt, 2 shirts, 1 person, 2 people, 3 people, something along those lines. If I have continuous data, that would be where my x values could be decimals and fractions. Remember that discrete data is only points. Continuous data is where the data has, the data in between our data points actually has meaning. Thank you very much for watching the video. Remember, if you have any questions, bring them to me tomorrow, and have a great day.